we'll say that we have x equals c is a 0 of a root or an x-intercept of the function p of x if when we evaluate our function at c, we get 0. Another way of saying this is that the graph of p is going to meet the x-axis at c. And so there are multiple ways that it could meet it. Either we could cross it or we could touch it, like y equals x squared. Let me draw just a quick sketch for this. So we can find this by solving p of c equals 0. If we have a graph given to us, any time where our output is equal to 0 is going to give us a root or a 0. Yeah, these names are mean the same thing. So anytime that our output is equal to 0, we'll have what's called a 0 or a root. So what I'd like you to do is take a moment, look over this graph, and identify the zeros of this polynomial. Okay, so we can see 1, 2, 3 places where our y value is equal to 0. And so we'll say that the zeros are x equals -2, x equals 0, and x equals 2. Okay, so the graphical picture is helpful for us, but we might be given, for example, an expression like this, where we want to use algebra to find these zeros. Okay, so here we have p of x equals x to the 5th minus 4x cubed. We want to find the zeros. So that means where the output is equal to 0. So we're going to change our output here to 0. 0 equals x to the 5th minus 4x cubed. And what I'd like you to do is just pause this for a moment. Give this a try. Okay, all right, and so we can simplify this. We see a common factor of x cubed, so I'm going to pull that out. I have x cubed times x squared minus 4. X squared minus 4 can be factored further. So you want two numbers that multiply to -4, but add to give you 0. So this is x cubed times x minus 2 times x plus 2. Okay, and now we have this product, it's equal to 0. So 0 equals x cubed, or 0 is x minus 2. 0 is x plus 2. That gives us 0 is x, x is 2, or x is -2. Have 3 zeros. The next thing we're going to look at is what's called the multiplicity of a 0. This is the power n for which x minus a to the n is a factor of p of x, where a is a 0 of your polynomial. Okay, so in this last example, we have x cubed times x minus 2 times x plus 2. We can actually, I'm just going to spend a moment just rewriting this so that it looks like it has this format x minus something. Another way we could write this is x minus 0 cubed times x minus 2 times x plus 2. And what we'll say is that the multiplicity of x equals 0 is 3, because we have a third power of that term. we'll say that x minus 2, that this term, because this term x minus 2 has a secret 1 here, we'll say that it's 0, x equals 2, has multiplicity 1, and x equals negative 2, that's 0, negative 2. When we look at the term that it comes from, again, there's nothing written here, so there's a secret 1. And so we'll say this has multiplicity 1 as well. So the multiplicity just means how many powers of the expression x minus that 0 appear as factors in your polynomial. So you have to have everything like all factored out in order to talk about multiplicity. So we're going to take a quick look at this example just to make sure we have the feel of this. So here we have a polynomial. 3 times x minus 2 cubed times x minus 1 squared times x plus 4 times x squared plus 7 cubed. So our first step before finding the multiplicity of our zeros is figuring out where our zeros are. Okay? So what we're doing is we're going to solve 0 equals 3 times x minus 2 cubed times x minus 1 squared times x plus 4 times x squared plus 7 cubed. Okay. Right. Well, looking at these at all of these terms, the things that can give us zeros are going to be the terms that are linear. Here, this value 3 can never be equal to 0. But we could have 0 is x minus 2 cubed. We could have 0 is x minus 1 squared. We could have 0 is x plus 4. When we look at x squared plus 7, we see that this is an irreducible quadratic. X squared is always 0 or more. We've pushed the graph of x squared up by 7, so it never touches the x-axis at all. And so only these 3 terms give us zeros. So this first term tells us there's a 0 at 2. The second one tells us there's a 0 at 1. And the third term tells us there's a 0 at negative 4. To find the multiplicity, we're just going to see once everything has been factored out and grouped so that all the powers are grouped together, we look at what powers we see. So at 2, x equals 2, this 0. We look at the x minus 2 term, and we see that it has a power of 3. So the multiplicity is 3. If we look at the x equals 1 term, this is a 0. It came from this x minus 1 squared factor, which has power of 2. This has a multiplicity of 2. And then finally, for x equals negative 4, we look at the x plus 4 term. And here the multiplicity is equal to 1. So no power is written, but there's a 1 there when nothing is written.